Here's one I prepared earlier. So yeah, you sub in x is 3 and x is minus the third, and you get 203 over 27. Note the use of a top-heavy fraction rather than writing 7 and 14/27. Actually, I have a feeling that's wrong, but anyway, I did this one without a calculator, so yeah, my apologies. Anyway, the point is you sub it in, you get the y values, and then comes the important bit. I'll write 203 over 27 for now, although I have a feeling that that isn't correct, but anyway. You know, therefore, that you have 311 as your first coordinate for a stationary point and minus a third 203 over 27 or wherever it was as your second coordinate. Now, a lot of people looked at this and said, okay, this y value is bigger than this one, so that's a max and that's a min. That is not a sufficient argument. Okay, it is true for a cubic. That will be the case because of the nature of the sort of wiggly shape of it, so you're going to end up with something like that. But we have to apply a more general argument because there are curves where this wouldn't necessarily be true. As soon as you start getting into quartics or 9 ticks or 37 ticks, it's going to be wiggly all over the place, and just because one point is above another doesn't necessarily mean that you have a maximum, for example, below. You can have a maximum below a minimum, because all the maximum means is that the curve's going from positive to negative, the gradient's going from positive to negative, and a minimum, the gradient's going from negative to positive. So yeah, anyway, the key thing is to work out what type of stationary point you have, you've got to differentiate again. So we take our dy by dx, we get the second differential, and this gives us 6x minus 8. And then we have to plug in the values of x at these coordinates and work out what this is. And as I said, if it's a maximum, then the gradient's going from positive to negative. This differential of the gradient of the gradient, if you will, tells us how the gradient is changing. So here, where we have a maximum, the gradient's going from positive to negative, and so the gradient is becoming more negative, which means that the second differential, if it's a maximum, will be negative. Likewise, at a minimum, the gradient's going from negative to positive, it's becoming more positive, and so we would expect the second differential to be positive. So we're going to do the second differential, we'll plug in the values of x. If the answer is negative, it's a maximum. If the answer is negative, is positive, it's a minimum. So there is a special notation. Actually, I'm not going to use that because that might confuse you. So we'll just say x equals 3, d2y by dx squared equals 6 lots of 3 minus 8, which is 10, which is more than 0. Therefore, if it's positive, it's a minimum. And then we do the same for x equals minus a third. d2y by dx squared is 6 lots of minus a third minus 8, which is minus 10, which is negative, and therefore minus a third, 203 over 27 is a maximum. And yes, you can look back at the curve and say, well, it's a positive cubic. Of course, the maximum comes first, but that is not a sufficient argument. And that's because more complicated curves require you to use this technique. There is a further technique which you need to deal with if d2y by dx squared is 0. We'll come to that another time. So, factor and remainder theorem, very straightforward. If you're dividing by x minus 1, you simply plug in 1. You do need to show your working. So it's going to be 2 times 1 cubed plus 5 times 1 squared minus 59 times 1 plus 28. And seeing as 1 cubed and 1 squared is always just 1, it's 2 plus 5 minus 59 plus 28, which is minus 24. And if you didn't put the minus in, you lost a mark, so be careful. This is important. It's only worth 1 mark, but it's pretty self-evident that when you plug in 4, it's going to end up being 0. So you need to show your working first of all. And I suppose it's quite a lot of working for 1 mark, which is unusual because normally with the kind of show that question, you get marks as you go for working. But in this one, it's slightly more punitive. So you get this answer, and that is not the end of it. Unfortunately, showing that f of 4 equals 0, you then need to write this statement. You need to say, therefore, x minus 4 is a factor of f of x. And if you don't say that, you don't get the mark. So please remember to do that. Finally, it says hence solve the equation. And we went through all kinds of different ways of working out how to factorize a cubic once you've got one of the factors. So we know that 2x cubed plus 5x squared minus 59x plus 28 is equal to x minus 4 times something. And at this point, you can use a number of different techniques. A lot of you went for the kind of quick fire technique, which is the one I like, where you basically just sort of match up the numbers. So we know we need to end up with 2x cubed. So that's going to be x times this, which means that this has to be 2x squared. We know that the numbers are 28, so the minus 4 is going to have to multiply with this. So we need to have a minus 7 at the end. And then you just look at either one of these and remember that there are two different ways to get them. So if we look at 5x squared, we can either make x squareds by multiplying this by minus 4. And if I'm writing out this formally, I'd say equate x squareds. So we have 5x squared on this side. And on this side, we have minus 4 times 2x squared, which is minus 8x squared. And if I call this ax, then the other way we make x squared is multiplying this number of x's by x, which gives us a. And so because 5 is minus 8 plus a must be 13. 13x. That's the quickest way to do it, but there are plenty of other methods. One of the methods that I think people quite liked was that sort of box method. So you know that you've got x minus 4. This is just another way of doing the same thing. You know you need to end up with 2x cubed plus 5x squared minus 59x plus 28. And again, so what needs to go here, here, and here? Well, there's only one way to make the 2x cubed. So we're using very similar logic to what we did before. It's just another way of setting it out. So x times 2x squared has to make that. And because we got 2x squared here, when it multiplies by the minus 4, it's going to give us minus 8x squared. And then to end up with the 28, we need to have minus 4 times something to give us the 28. So that has to be minus 7. And because we've got a minus 7 here, that gives us minus 7x. And then we just look what needs to go here, again, to make the right number of x squareds. You've already got minus 8x squared, so to get plus 5, we need to add on 13x squared. And to make 13x squared, that's going to have to be 13x. And then we can just double check that it all works out by doing 13x minus 4, and we get minus 52x, which minus 9x makes correct, and it all works out. The other method you can do, which some people like, personally, I think it's a bit too much working, and there's a lot of unnecessary calculations that are involved, but you can do it like this, and you will, if you go through that correctly, get 2x squared plus 13x minus 7, but I can't bother to go through that. I don't like that method, but some people do. It's fine. Anyway, that's not the end of the story. So apologies if you got this method and you've been waiting to carry on with the question. You can join us again now. Once you've got this, you are solving the equation. So we know that x equals 4 is one of the solutions because of that factor, but we need to know the solutions that go with this. Again, you can apply the quadratic formula. This one happens to factorize quite nicely. It's going to give us minus 1 plus 7. And so we get x equals a half or minus 7. Don't forget, though, that we've also got that solution that we already had at the beginning from this one. So it's x equals a half or minus 7 or 4. All three of those are solutions, and that solved it. It's a lot of work for 4 marks, but that's hard maths. Right, this was the biggest question in the paper. It was worth 11 marks, so if you got this wrong, it was pretty expensive. And I should point out that binomial always comes up in AdMaths, and it's always worth 12 marks. Well, actually, I say always worth 12 marks. It is almost always worth 12 marks. It's a big, big part of the paper. So if this was expensive for you this time round, it's definitely a topic that you want to get sorted. Let's go through the 3 questions. These 2 are quite typical questions. Actually, this one doesn't come up that often, and maybe the 4 marks turned out to be generous because a lot of people got it right with not much working, but I'll go through the answers anyway. If Jerry watches 10 videos, what's the probability he laughs at all of them? So he laughs at 60% of the videos, which means that there's a 60% chance he'll laugh at the first one, there's a 60% chance he'll laugh at the second one, there's a 60% chance he'll laugh at the third one, and so on and so on. So the probability he laughs at all 10 is going to be 60% times 60% times 60% times 60%, which is 0.6 to the 10, which comes out as 0.006 something. If you left off the something, you did lose marks, because as a general rule, you want to answer to 3 significant figures. In probability, there's a slightly different convention because your answers are always between 0 and 1. And so in probability, we tend to say 4dp. So 1, 2, 3, 4, there should be one other number. I can't remember what it was, but it's pretty easy to check. But do make sure that this would be insufficient to get full marks, 0.006. If he watches 10 videos, what's the probability he laughs for at least 2 of them? Okay, so this is a pretty standard binomial question, made complicated by the fact that it's at least 2. So he's going to watch 10 videos, and he's either going to laugh at 0 of them, 1 of them, 2 of them, 3 of them, 4 of them, 5 of them, 6 of them, 7 of them, 8, 9, or 10 of them. If we're looking for the probability of him laughing at least 2 of them, how many does he need to laugh at? Well, he needs to laugh at 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9 or 10. So one of the ways of doing this is we could work out the probability for 2, the probability for 3, and so on, and add them all up. By far the easier way is to work out the probability that he laughs at none of them, the probability he laughs at 1 of them, add those up, and then subtract them from 1, which is what most of you did. So the probability he laughs at no videos, we can write like this, P0. If he laughs at them 60% of the time, he doesn't laugh 40% of the time. So the probability he doesn't laugh at any of them is going to be 0.4 to the 10, which is some very, very small number. I think it's something like 0.00018 or something, but I can't remember. And then the probability he laughs at 1 of them, this is a classic binomial, so we're looking at NCR 10C1 times 0.4 to the 9 times 0.6. Now, for those of you who don't know where those numbers come from, he watches 10 videos, he either laughs or he doesn't, right? So because we're looking for the probability of him laughing in 1 of the 10 videos, the easiest way to think about where this comes from is to think of a sequence of 10 results for which one of them would be laughing and the rest wouldn't. So, for example, not laugh, 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 laugh, right? 9 not laughs followed by 1 laugh. That is one of the ways in which he could watch 10 videos and laugh at 1 of them. He'll either laugh at the 10th one, or the 9th one, or the 8th one, or the 7th one, or the 6th one, or the 5th one, or the 4th one, the 3rd one, or the 2nd one. In effect, there's 10 different ways of rearranging these, which is where this number comes from. 10C1 is the number of ways you can arrange 1 success out of 10 events. So we work out the probability of a specific sequence, not laugh, not laugh, not laugh, not laugh, not laugh, not laugh, 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 laugh. So 0.4 times 0.4 times 0.4 times 0.4, 9 times 0.6. And then we multiply that by the different ways we could rearrange these. That's how this probability comes about. It comes to 0.00034 or whatever it is. Again, I can't remember. And then those are the 2 ways, that's the probability of 0 and the probability of 1. We add those together, and then we do 1 minus that. And so we worked out the probability of 0, the probability of 1, and then everything apart from that will give us our answer, which is something like 0.998. And again, either three significant figures or 4DP. So 3SF would probably be fine here. I'd say probability, probably best to go with 4DP, so it'd be 0.9988 or whatever it turns out to be. I can't remember. How many videos does he need to watch so that the probability of him laughing at least once is above 99%? Right, so if he watches 1 video, the probability of him laughing is 0.6. If he watches 2 videos, the probability of him laughing at least once, well, there's 3 different ways it could happen. Either he laughs at both of them, which is 0.6 squared. He laughs at the first one but doesn't laugh at the second one, which is 0.24. He doesn't laugh at the first one but does laugh at the second one. And if you add those up, you get 0.84. And we could keep going like this, but this is obviously a very time-consuming way. 3 videos, you could laugh, 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 not laugh, 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 not laugh, not laugh, 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 not laugh, laugh, not laugh, not laugh, not laugh, laugh, etc. I think I haven't even covered all of them yet. There's anyway. It's going to get very confusing. Basically, this is not the right way to think about this. The best way to think about this is that if the probability of laughing at least once is 99%, then what that means, whenever you see the phrase at least once in probability, you should also always be thinking about the opposite of at least once. So if we go back to our line here, at least once, however long this sequence of numbers is, every number from 1 onwards. It's everything apart from 0. So when it says the probability of him laughing at least once is above 99%, the probability of him not laughing at all is going to be less than 1%, or less than 0.01. And that's really where our answer starts. the probability of not laughing at all has to be less than 1%. And so if we flip this on its head, that is not a good way to answer this question. The probability of not laughing for one video is 0.4. The probability of not laughing for two videos is 0.4 squared, which is 0.16. So we're down to 16% already. The probability of not laughing for three videos is 0.4 cubed, which is 0.064. We're down to 6%. The probability for four videos is 0.4 to the 4, which is 0.0256. We're on 2.5%. 5 videos, 0.4 to the 5, 0.1012, I think. We're down to 1%, and then 6 videos, we go under the 1% threshold because of 0.0004048 or whatever it is. So, oh yeah, I'm off screen, sorry. So yeah, if we're looking for when the probability of him not laughing dips below 1%, we get there at 6 videos. Now, without knowledge of how to use logs, that's the only way you can answer this question. There is a log way of doing it. I'll put it in just because it's nice to know. Our equation is basically saying 0.4 to the n is, I'm going to write is equal to 0.01 because actually the less than involves something a little bit confusing. So we're just working out how many times you multiply 40% by itself to get down to 1%. If we take logs of both sides, log of 0.4 to the n equals log of 0.01, then a useful little trick happens with the n. The n can move to the front for reasons which we'll explain when we do logs, which is not this year. And then n times log 0.4 equals log 0.01, and so n equals log 0.01 divided by log 0.4, which comes out as like 5.02, which means that if you do it 5 times, it won't be enough, but 6 times it will. Anyway, the answer is 6. And if you just wrote the answer 6, I gave you all 4 marks, which was a bit generous because you could have copied it off the person next to you. But yeah, trial and error is the way to do it. And again, you wouldn't necessarily need to do 0.4 to the 2, 0.4 to the 3, and so on. You could do 0.4 times answer and then just tap the answer button until it comes up with a number that's less than 0.001. Wait, do I mean, I've messed this up, haven't I? This is, it should be 0.0246 and yeah, sorry, too many zeros. Anyway, you get the idea. Yeah, nobody really knew what this was about. Well, no, not nobody. Some people did get the answer, but most people were a bit flummoxed. We did do this a long time ago. When you are integrating when we did the question before, when you had dy by dx, the gradient of the curve, and you had to work out what the curve was, and you had that plus c thing, hopefully that made sense. You're working out what would differentiate to make dy by dx. This is a different type of question. This is saying we already have this curve, x cubed minus x. What does it look like? Oh, it's, sorry, I can't think. I think it looks something like this. It goes through the x-axis at 1 and then goes on to 4. And we're saying, what is the area of the curve under here? And I've made it look a bit triangular-y, which is probably misleading. Let's make it look a bit less triangular-y. And the way that you find the area of a curve is basically by splitting it into infinitely thin rectangles. And I won't go into the theory of integration now because you just want to know how to get the answer for the time being. So what that means is that you sum all the values of y times dx. So basically, a lot of you said, because you knew it was something to do with integration, wrote down x to the 4 over 4 or a quarter x to the 4 minus, so I wrote a quarter x to the 4, this most people wrote minus a half x squared. And then some people wrote plus c, but this is the starting point. The way that we get the answer is we integrate and we get a quarter x to the 4 minus a half x squared. And then the significance of these two numbers, the 1 and 4, which when you put them in the square brackets, you have to put at the end. Do you remember this vaguely? Because now we substitute in 4 and we substitute in 1 and we subtract them. So we substitute in 4, we substitute in 1. So this is a quarter of 4 to the 4 minus a half of 4 squared minus a quarter of 1 to the 4 minus a half of 1 squared. And so from this we get 64 minus 8. And this one we get a quarter minus a half, which becomes 56 minus a half and minus a quarter, sorry, and the answer is 56.25. Yeah, so this is something we've done before. It's, as you can see, it's not massively complicated. So I think if well, most people did figure out how to do it because we probably didn't spend very long on it. But the basic idea is when you're integrating between limits, you use that to work out the area under a curve. You integrate, there's no plus c this time because that's not how area under a curve works. You basically get the values of these integrals. You plug in the upper limit and the lower limit, you subtract them, and the difference between them gives you the area under the curve. There are reasons for this, which are explained probably on lots of other YouTube videos, but that's how you get the answer for now. Okay, this was a very difficult question. Which is odd because in some ways the maths involved is something that you probably could have done, well, seeing how it works is in principle something that you could have done from year 7, but most year 7s wouldn't really be able to set up this diagram. And there are reasons that make this question more difficult than your average bearing question. So let's begin. Ship A is 71 kilometers away from port X on a bearing of 235. Now, just interpreting that sentence causes some confusion. If it's away from port X on a bearing of 235, that means the bearing from X to A is 235. So if we put X over here, if we're looking for a bearing of 235, that's 0, that's 90, that's 180, that's 270. Because remember, bearings are basically a numerical form of direction. 235 is somewhere this way. It's a bit more west than southwest. But anyway, that's the direction that... if that's X, then A is over here, and that distance is 71. You then have to read the next instruction carefully because it's quite confusing. It says, ship B is 52 kilometers away from ship A and on a bearing of 271 from port X. Now, those are two separate pieces of information. It's on a bearing of 271 from X, so it's basically west of X. And it's 52 kilometers away from A. Now, I don't know if you remember all your construction stuff, but to draw the points that were 52 kilometers away from shape A, you would draw a circle, right? And that circle would have a smaller radius than this line because this line is 71, which is more than 52. So if this is 52, roughly, then you would draw a circle of this kind of radius. And you would notice if you drew a circle of this radius that it would cut, that's a terrible circle, but never mind. It actually cuts the line twice. So there are two answers to this question. It's not an atypical question, but it is more difficult than your average one. So B is either here or here. That's really unpleasant. I think maybe I'll take this example first. Okay. Now, working out what the hell's going on in this is really not that straightforward. I suppose the key thing, because this is quite a typical A-level type question, is that two of the lines, you know the direction they're going in, and one of them you don't. And so that's going to give you the angle inside the triangle, the first angle inside the triangle. Now, the lines you know the direction of, you know that the bearing of X to A is 235. So we know that angle is 235. And the other line we know is that the bearing of X to B is 271. I'm going to struggle to draw this neatly, but that's 271. Which means that because we know which direction this line is going in and which direction this line is going in, we know the angle between them. It's the difference between 235 and 271. So we know that this is 36. And that will help us work out what's going on. I'm just going to flip to my sketch so I can remember how to do it. No, it's not that bad. Now, just looking at this triangle, you know this is 71, you know this is 36, you know this is 52. So it's not a right angle triangle, obviously. And then to work out which rule we're going to use, we need to look at whether we have a pair of angle and side. So do we have an angle and its opposite side? And we do. We have 36 degrees here, we have 52 here. Now, if you have the pair of the angle on the opposite side, you're going to use sine rule to work out the next bit of information. So what we want to do now is work out what's going on in this triangle. So we say, if we know this pair of angle and side, we can use the pairs with sine rule to work out what that angle is. So if we call that angle B, then we can say sine B over 71, remember this, equals sine 36 over 52. So sine B is 71 times sine 36 over 52. And we get B is 53.4 degrees. Now there is actually another answer, but until we've done a bit more trigonometry, we won't know what that answer is. I'll come back to that when we do trigonometry again. So this is the result that you'll be able to work out. The other one requires us to know a little bit more about what happens when we do inverse sine. So we'll get to that. Now, this angle is 53.4 degrees. We are trying to work out the bearing of ship B to ship A. I think it's probably useful if I draw the triangle out again, just because it's all starting to get very messy. So this is 36, this is 71, this is 52, and this is 53.4. We know that that's north, or north or 0, I suppose. So this is 89 here. Now, there's B, there's A. We need to work out the bearing from B to A. We know that this is 53.4, but how do we work out what that is? Well, in this particular case, there's quite an easy way to work it out. And hopefully, I've given you a clue here. As a general rule, when you're trying to work out what's going on with the bearings, it's a very good idea to draw northerly directions going from your vertices. So here's X. If I draw a north line here, and if I draw a north line here, we know that this is 89 because X to B was 271, remember? It's basically 1 degree over west. So because this is 89 and this is north, and because this is north, do you remember all that corresponding alternate business? Yeah. These two lines are on the angles on the inside of the parallel lines pointing to north, which doesn't mean that they're the same. It means they add up to 180. So if that's 89, that's 91. And if that's 91, then the bearing is going to be 91 plus the 53.4 you worked out. And so the bearing is 144.4, yeah. I appreciate that you probably found that quite tricky. We will definitely work on sort of difficult sine and cosine rule questions again when we come back to trigonometry. Yeah, that was a tough one. Anyway, a couple of people did get it right. Henry Hall, shout out. Anyway, moving on, the last two questions. If air resistance slows it down at 4 meters per second, how long does it take for the ball to stop? Again, you didn't really need to know any kind of VUAT to realize that if it's slowing down by 4 meters per second every second, that's going to take 5 seconds. And if you just wrote 5, I gave you the answer. The SUVAT equation that would have given you that actually is applying it in a SUVAT way would be more tricky because you've got the initial velocity is 20, you've got the final velocity is 0. You've actually got a deceleration of force, that would be -4. And then the equation that links V, U, A, and T is VUAT. So V equals U plus AT. And you would have got 0 equals 20 minus 4T, and so T equals 5. The way to do it without SUVAT would be to have a velocity time graph, as I said, and it's going from 20 down to 0. And if the gradient is 5, then 4 rather, then that would have to be 5. Likewise, if you've got that graph for velocity against time, then to work out the distance traveled, you could just do the area of that, which is going to be half of the base times the height. So half of 5 times 20, which is 50. The other way you could do that is to use average velocity. If your start velocity is 20, your final velocity is 0, your average velocity is 10. So if you travel an average velocity of 10 for 5 seconds, that would just be 20 plus 0 over 2 times 5 is 50. And that's shove it, actually. That's U plus V over 2 times T equals s. But again, these equations are something we barely did. So the way to do it without those equations would be to look at a diagram. We will get familiar with those equations. This one was very tricky, deceptively so. And I think only Luca worked out what we had to do here. This is not constant acceleration. It varies with time. So the whole Suvat stuff is out the window here. We have to use a different connection between acceleration and velocity. And you will remember, I hope, we did talk about this before, that acceleration is the rate of change of velocity. So this is a bit like where it said the gradient of the curve is this. What curve did it come from? Velocity will be the integral of this. So it'll be velocity is minus 2t squared minus 4t plus c. Now, what the hell is the plus c? Well, it's about velocity and time. So to work out what the plus c is, we need to know what a value of the velocity was at a particular time. And we know that when Shaq kicks the ball, he kicks it with 20 meters per second. So that means when it starts, t is 0 and velocity is 20. So we plug that in here. 20 is equal to minus 2 lots of 0 squared, minus 4 lots of 0, plus c. And of course, all the 0 terms are just 0. And so c is 20. So we have the velocity equals minus 2t squared minus 4t plus 20. And we want to know when the velocity equals 0. So we just solve that equation. Minus 2t squared minus 4t plus 20 equals 0. Divide by minus 2, we get t squared plus 2t minus 10 equals 0. And then I would solve this either by the quadratic formula or completing the square. T plus 1 squared minus 11 equals 0. T plus 1 squared is 11. T plus 1 is plus minus root 11. So t is minus 1 plus minus root 11. And obviously the negative time solution is wrong. So we are looking for t equals minus 1 plus root 11, which comes out as 2.32. Yeah. Last question. Expand 1 plus x to the 4 using the binomial expansion. So lots of people did it without using the binomial expansion, and they got the answer right, which is great. But let's remember the binomial expansion comes from Pascal's triangle. We have this. And this is what you get when you expand successive terms in 1 plus x for reasons which I hope we discussed enough. But anyway, we're doing the fourth expansion, so we're looking at this row. So our binomial coefficients are 1, 4, 6, 4, 1. You arrange ascending powers of x, so it goes x to the 0, x to the 1, x to the 2, x to the 3, x to the 4. Cross off the 1 here because you don't need it, and that's the answer. That was easy, wasn't it? Binomial expansions do get more difficult when this isn't a 1, but not much. And that's 4 marks. When it says using terms up to x squared only, it means the terms in ascending order. Some people wrote this the other way around, which is fine. But we're just going to use that. So we're saying 1 plus x to the 4 is approximately equal to 1 plus 4x plus 6x squared. How does that relate to 1.01 to the 4? They look extremely similar. And we know that the 1.01 is 0.01 more than 1, which would mean that we could think of this as 1 plus 0.01 to the 4. i.e., if x is 0.01, we get this. So we just replace the x's with 0.01. So we get 4 0.01s, 6.0.01 squared, and we get 1.0406, and that's the approximate value using the binomial expansion. What was the point of that? For more complicated calculations, the binomial expansion does give us approximate values for difficult calculations. Anyway, that was the test. It was pretty hard. I would hope that you found that helpful, and we will be revisiting these questions again soon. Thanks.